Okay, 13-7. Our math objectives are: I can model whole numbers using different fraction names. I can use fraction names to represent whole numbers greater than 1, larger than 1. And I can explain my thinking and show my work using academic words, numbers, and pictures. Jack ate 6 pieces of cake during the week. Each piece was 1/6 of the whole cake. How much cake is left? You're going to need to demonstrate this as your solve and share. How can you prove your answer using the fraction bars? Can you prove it using a drawing or diagram? And use math vocabulary to explain your thinking. So we're looking at those words like numerator and denominator and equivalent. Let's start with this here. We've got a number line to complete. So I'm going to count. I always like to count the hops first on my number line and just see what we're counting here. It looks like they took this number line, went from 0 to 2. So I see 2 holes. There's 1 hole right there. There's 2 holes. So there are 2 holes on this number line. And I see the 3's for the denominator. That means they divided these holes into 3 equal parts. All right, let's check here. What do we have? There's 1, 2, 3. Yep, there's 3 equal parts for the first hole. And 1, 2, 3 equal parts for the second hole. Okay. Now I can fill in our fractions here. Let's see, that was the first third right there. Yep. Okay. 2/3. I know this is going to be 3/3 because 1, 2, 3. That there we go. 4, 5. That means this must be 6. And again, I always want to double check my work. So if I count those thirds, let's see, was that, yep, there was 1, 2, 3, 4, 5, 6. Okay. Count those thirds. So I noticed that when I got to 3/3, 3/3 is the same as 1. 3/3 is equivalent to 1. I'm going to write that over here just because I like to remember it. 3/3 equals 1. Okay, now let's see that. There's 3/3 equals 1. I also see 6/3. 6/3 equals 2. Here's my fractions. Here's my whole numbers. I'm representing a whole number with a fraction. It's another name for it. There's another name for this whole number, and it is a fraction 3/3. Another name for this whole number is the fraction 6/3. Okay. They are equivalent, equals, the same as. Let's see what we have here. Oh, now we divided into sixths. So up here we divided it into thirds. Now we divided it into sixths. Well, the first one is going to be 1, isn't it? 1/6. That means we're going to have 2/6. Well, 3/6, 4/6, 5/6. Can you guess what's next? 7/6. There's 8. So I'm kind of checking I'm on the right path. 9, 10/6. Gotta squeeze my numbers in here. 12/6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Always good to go back and check and make sure you didn't skip one, because sometimes you would just go 7, 8, 9 because you don't realize they've already got the 8 in there. So be careful. All right, so now I have some other names. I have some fractions. Divided the line into thirds, also divided the line into sixths. And now I have some sixth fractions down here. And there's another name for these holes. Let's see, what equals what? Another name for the whole number 1. Here's my whole number 1. Here's another name for it. 6/6. Okay. 2. What's another name for this whole number 2? Whole number 2 is 12/6. Another name for it. So again, I can name these whole numbers with a fraction name. I can represent the wholes with fractions. I also noticed something as I'm looking at these numerators and denominators. Notice how the denominators always stay the same, but my numerators, 3 and 6, 6 and 12, looks like I'm multiplying. 3 times 2 is 6, 6 times 2 is 12, but I never changed the denominators because we've still broken the line into sixths. So you never change the denominators, just the numerator that changes. All right, here we can look back at our number line. Okay, here's I'm going to look at my number line. Write two equivalent fractions, two fractions that are the same for each whole number. Well, I'm going to find my number 1 here. There's my number 1. Give it a little highlight, and I want to find a fraction that is the same. Well, that means it's going to be in the same line. So look at that. 3/3 is the same as 1. And how many sixths are the same? 6. There's our fractions that equal 1. Let's find our number 2. There's my number 2 right there. I want to find a fraction that is the same, is equivalent. So I look here and go, ooh, 6/3 is equal to 2. They're in the same spot. If I jump by thirds or I jump by whole numbers, I'm going to end up in the same place. So 6/3 is equivalent to 2. All right, let's try it with sixth. I can jump by wholes, 1, 2. I can jump by 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sixths is equivalent or the same as 2. 2 equals 6/3 and 2 equals 6/12, which means also that 6/3 equals 12 sixths. 6/3 equals 12 sixths. Okay. Rewatch this video. You can do it a couple times, pause it anywhere you want, work out the problems for yourself. Remember that you can use your fraction bars here. Here's my two holes, and if I keep filling in those sixths, I've got 6 of them is 1, 10, 11 sixths, 12 sixths is equal to or equivalent to 1. So if you want to come to your fraction bars and double check, there's 6 sixths equals 1, 12 sixths equals 2 wholes. Work out the problems. 13-7 video on Pearson. Pause, think, and do the work. There's a little try it button. Click on that try it button and test it out. It's good practice. 13-7 practice buddy. 13-7 solve and share. Show us what you know. All right, good luck. Have fun.